All right, I may start a minute or so early just to fit all this in. But let me make sure my audio stream is there. And I thought I was streaming. Okay. Oh, okay. Okay, let me go ahead and start. I know it's a touch early, but what my goal here is to work through this problem. Okay, so he says first, okay, this is working off of the other chapter. Let me see if I can find it. It's working off of this chapter. What I'm going to do first, instead of doing the integrals first, I'm going to do the composite sections first. That means, and this is more in line with what you would be doing in industry. Composite sections are something like this. You have a 1x8 right here, connected to another 1x8, maybe nailing it, gluing it, you've created a beam. So it behaves a little bit different than two pieces individually. So the key is moments of inertia, area, so it should say area moments of inertia. Okay, moments of inertia of the area. Okay, so that's okay. About the x-axis. Okay, now, like I said, I'm going to come back to do the integrals because right now I want to do the composites because I'm going to address that first, and then I'm going to come back. There are two phases to this. Phase one is find the area moment of each composite and move them to a proper location. You move them using the parallel axis theorems, which are written up there, but they're written again right here. And so this is what we're about to do. Now I've got one situated already on the page. Now we go over, and I did a search, and it ended up at the Wikipedia, and this is okay, list of second moments of the area here. So he's got a circle with a hole, kind of a funny thing, a semicircle that's shifted down, one that's a semicircle here, quarter circle, then quarter circle with a different location. And this is the one we're going to focus at for this particular one. So it's 1/12. Okay, the IX, think of it as though you're spinning about this x-axis. So the IX is 1/12 base times height to the third. Now, I'll show you next time how actually you can integrate this thing. And this one right here will be the same. So this one right here is actually the same as the one right there. It's just that the X and Y axis is located here, not at the centroid. Here, it is located at the centroid. So this table is a little weak, but it's okay. And so there's the parallel axis theorem. If you go here, you'll see a little bit of the derivation. I think our book does a reasonable job of that. This might be a little too much, but it's okay. Go back. So let's get to work. First thing is determine the y bar. Okay, so what I'm going to do is I'm going to create this one being, or identify this one as being 1, identify this one as being 2. I'm going to try to make my tables as long as I can. I'm going to put my areas right here. Now the first thing he is moderately interested in is the y bar. The x bar is pretty easy because it's symmetric about this side as it is about that way. So if you cut it right down the middle, it'll be a mirror image of each other. So there's no real reason to find that. But the y bar of each section there is. Okay, first let's deal with the area. I've identified this one as being 1. So the area of 1 is equal to 20 times 150, or let's see, let's go ahead and do this. We're going to keep these back and forth. 20 times 150. These numbers are going to kind of get fairly large. So the area of 1 is 3,000. The area of 2 is equal to, okay, that's a 150 and that's a 20. Oh, okay, 20 by 150, and that's 3,000. Where is y bar? Okay. Now, what we have to realize is where is my x? He is identifying. Let's take a real close look here. He is identifying this distance. So I believe what he has determined, this is the case. If that's the case, centroid of 1 is right here. Centroid of the other is right down here. This is a distance which is half of 20, which is 10. This is a distance which is 20 plus 75. Okay, so 2 would be 10. 20 plus 75, I believe, is 95. So now, a y bar. Now, I have to apologize about the large numbers, but I'm going to try to make enough space here. So 3,000 times 95, 285,000. Let me double check that though. Yeah. Now this one's a little easier. 3,000 times 10 is that. So now let's sum this, that's 6,000. And let's sum this one, and that's that. Now, y bar is going to be equal to the sum of all my i's, in this case 1 to 2, of y sub I bar a sub I over sum I equal 1 to 2 a sub I, which would be 315 over 6,000, or move it to the top so I can do this. 385. No. 315. No. 315,000 divided by 6,000. 52.5. 52.5. So the distance here is equal to 52.5. And so let's accentuate these a little bit better. And this one is in fact the centroid of the composite. Now let's find the I. Okay, what is going on? I kind of see a tag right there, like he's asking for IX tag and IY apostrophe or whatever. So this means he is, let me see if I can, he wants to know it about here and about here, not about here. Okay, so now here's what I'm going to do. Now I'm going to move this over and maybe shrink it because maybe I need a little bit of space here. I can always zoom back in on it, and it probably will be okay. Or I can increase its size. So here's what you do. Bar X. Now I always write XX. Here's why. You have an object. Here's your X. Here's your Y. Actually, this is a tensor anyway, meaning there's two directions associated with it, because you will find out this, but then you also have XY. XY the area. So yeah, let me get back to the book for a second. Let me see if I can slide backwards. Okay. Here are the two things. Now, I'm trying to find out. Okay, he goes from here. He goes into the parallel axis theorem. Goes into the ratio gyration. He does not do that quite yet. Okay. Okay, well, I'm sorry about that, but this is, in fact, we're in composites. Let's see if he goes somewhere in here and describes this. Or basically, okay, here we go. Now, this one, the little asterisk says it's not necessarily required, but notice something interesting here. Before, he had this. Okay. Now, actually, there should be two of these that should be designated. So the X would be designated about here, and the Y would be designated about here. So, in fact, it is a tensor. It should have two subscripts. And so that's the way I write it. So when you see me writing this, this is why, because there is a second order term, meaning this one and that one. So just basically understand that that's what's going on. And apparently we don't necessarily have to do this, but if you notice there's a parallel axis theorem here, instead of a dx squared or a dy squared, there's two components. And so if you get deeper and deeper into this, you'll realize that you can do coordinate transformations to move from one to the other. I'm not going to get into that. I'm just going to try to get us to the point where we can solve this problem. So we don't have to do this. Now, right now, we're in composite section, which means I can go back over, slide up, and here's where I'm going to focus. Okay, he does not specifically say this, but this point in the center right here is, in fact, the centroid of this rectangle. So 1/12 base times height to the third. So let's go back. I'll write the equation here. 1/12 base of 1, which is this one, is 20. Height is 150 to the third. Now what I'm going to do is I'm going to take up a little extra space here, just because I'm going to put this over here. And what is the other one? It's 1/12. The base of it is 150, and height to the third is 20. And so let's slide up here. Oh, that's a different thing. Okay, let's see right there. Okay. 20 and 150. The third by 12 gives you, okay, 565. 5 times 65 times 0, 0, 0. Now, the other one, okay, 150 times 20 to the third divided by 12 is 100,000. Now, let's make sure we understand this about their own centroid, not the centroid of the composite. Now, why did I make these little dots here red? Because I need to move now to the centroid and to the centroid. I need to move the IXX. This looks weird. I need to move this distance to move the IXX bar to the IX bar, tail the X to it. And I needed to move, and this one I don't know what to do except to say this is for 1, this, and I need to move the I bar XX to the, I need to move it, so this would be 1, and I need to move it IXX where till tick tick 2. So I need to know this distance. Well, I know I move 10, and I know I move another, okay, so this is 10 from the top, 52, so actually this distance is 10 less, or 40 22.5. In other words, there's the centroid 10. Take that off. This is the distance I have to move it. Now this is a distance of 75. And I got to subtract 52 from that to get that distance. So if I do that, 75 minus 52.5, 22.5. Now, let's list those things. Those are dy's, and I need to move, okay, I'm making it a little too big. I need to move 22.5 to get to this axis right there. So it's 22.5. Now, I need to move to the upper one. I need to move it 42.5 to from the centroid of its own centroid to the centroid of the composite. It's 42.5. Now what I'm going to do is I'm going to look for a second at the parallel axis theorem, but to do that I need to move back. You can look at it on the web, but I don't want to do that. Here is my parallel axis then. Well, let's go to right. So I'm first dealing with this one. I'll deal with that y later, but I may not have to. Okay, so I take the value at its centroid, I move it away, so I have to square it, and then I have to multiply times area, and then I have to add these two to get that one. So let's see, how do we do that? Oops, wait a minute. Area dy squared. So take the area, multiply times that squared, and put it in that column. So here we go. Let's see. I'll slide it up. Wrong. Okay, so what I'll do, so go over here, take the 3,000, that's the area, times 22.5. We'll square it. Okay, 518,750. 518,750. Okay, again, I'll do it here. That times that squared goes right there. 3,000 times 42.5 squared. 5,418,750. Now what do I do? Now I want to do I x tilde x tilde is equal to I bar xx plus a dy squared. So a fairly wide column. So what I'm doing, pretty simple. Taking this, adding to that, and putting here. Okay. So zoom it in to the point where I can just sort of put it right there. Go back. 5,625,000 plus 1,518,750 gets me 143,750. Again, I'll do this. I'll take that. I'll add to that. And I'll stick it right there. Okay, 100,000, that's pretty small. 5,418,750 gives me 5,518,750. 518, 750, and we're good. Now what do I do? Okay, well, since I got two composites, I'll just sum them to get the answer. And so what do? I could probably just copy paste if I can find my mouse. Copy paste plus copy paste. Okay, a lot of digits, but 12, 662. 500. Did I copy the? I did not copy the. Okay. That's the problem. We see we have possibly an error. Let's see if we can figure it out. Okay, first of all, it did tell me 52.5. We don't have this. So we've made an error along the way. So let's not panic. I'm assuming that we made an error. In the dynamics a minute ago, back the book was kind of off on that. But let's assume this looks about right. So 16.6. See if we can go back and find our error here. Okay, so first, let's go back. Okay, so there's a good chance our error doesn't exist inside of here. So there's a good chance we're okay here. And the reason I say that is because we got the right value of A bar. The next question is, did I goof up either this or my distances? Let's start here on the first one. Okay, I bar XX. Okay, so base times height to the third. That looks okay. Now, there is a good chance that I goofed up on my calculations inside the calculator. So 1/12, okay, there's the 150. That's the base here. 20 is the height here. So I think I'm okay. Let's make sure I did not goof up in my calculation. Okay, 20 times 150 to the third divided by 12. 5628. I'm sorry, 5625. 000. Okay, now let's try this. And put the power of 3 over here. And it looks like I got 100,000 there. My distance, y. Okay, so let's take a look and let's be very, very careful here. What is the distance it has to move to? Is it 42.5 for this one, for the upper one? Did I swap these backwards? And is it 22 there? Okay, let's take a look here. It's 52. So if I add this distance to this distance, I should get the 75. In other words, here, let me do it like this. If I add that distance to there, and the distance to here, what should I get? I should get 52.5, and I'm saying 22.5. That'll be 5, that'll be 75. So that checks out. I think we're okay there. And then 42.5. Okay, so I'm having to move from here down to the centroid here. Is that the correct distance? So if I add 42.5 plus the 10, I should get back to. Now the question is, do I put them on the right columns? Okay, so the 150 to the third, 150 to the third should be the 22.5, because this is this one. This is area 1, goes in this row, goes all the way down to here, and we're okay there. Area 2 is at 42, so it says 42. It's this area, area 2, row 2, and it's 42. So I think I'm okay there. Now, the areas are both 3,000. Let me see. Move up. Just make sure 22.5 squared times 3,000. That's the value there. 42.5 squared times the area of 3,000. Okay. And let's see. So if I add 5 and 6, I'm still getting that. So the I bar moving to there is okay. So I look at his 16. Okay, so 16, I actually question this. Now, let me go back and make sure. Oh, that's somehow got. Wait a minute. No, I am on that problem. Determine y bar, which locates the centroidal axis, okay, for the cross section. Then find the moments of inertia, x bar and y bar. Y bar is, I mean, what y asterisk and y asterisk and x asterisk. So, it is possible that I've made a mistake, but now what I'm going to do is I'm going to go ahead and go after this one, and any mistake that I might make might be accentuated or brought out here. So let's go back to it. Now, I don't like that color. YY, which in this particular case is 1/12. Now the base, okay, let's look at this thing. So here's what happens. This time we're operating at the YY. So the base and the height get flipped. 150 times 20 to the third, 112, and then 20, 150 to the third. Now what happens is I get 100,000 here, and I get 5,625,000 here, which means I sum those. I get 5,725. Oops, there's an extra 0 there. 000, which means it's 5.7 e to the 6. Okay, so we're right there. So the question is the parallel axis theorem, are we not transferring the right distances? Because the areas are straight up. So the subject or the target of my error might exist right here, or the target of his error. So let's take a look at these one more time. Now, we're going to stare at them for a second. If, in fact, this is 52.5, which it states that it is, and this is 20, and there's 10 here. So that means I add 10, I add this distance right here to that distance right there, and I've got to get 52.5. So I'm pretty sure about that one. Now, oh, wait a minute. Okay. All right, 22.5 suddenly becomes suspect. Here's why. It's 20 and then 75. Okay, so the distance down to this is from that other axis is 20 plus 75 will get us right down there. Okay, so 20 plus 75. Well, that's 70, that's 95. And 95 minus 52.5 equals to, let's see. Oops, wrong thing. Let's go back and let's go here. So 95 minus 52.5, 42.5. So this one is further down, and this is probably my error, and it is 42.5. Now, let's go back and say X, and then we'll say 42.5. Well, guess what? Since the area is the same, and these now are the same, this should be, tell you what I'll do. There's my old value. My new value is 5418, 750, which means that this is my old value here. And I should be able to move that out of the way and say, yeah. Now I'm looking to add this number to that number and put right here. If I slide up, and then I take 5625, 000 plus 5418, 750 equal to 11. Oh, I forgot already. 043, 750. Now, if I sum these, I do not get that value, and guess what I get? I get 11. Wait a minute. I can just do this plus 5518, 750, 16, 56. No, is it 562 or 52? 562, 500, or 16.6 or 16.56 e to the 6th. And I think we've resolved it. So he's right, and I goofed up on my distances. So when you saw me earlier in the lecture tell you that that was 22, it truly was not, because I forgot to add the 20 on here. So it was 20 larger than what it was, and that makes it 42. So there's my error, and it's okay. So we've solved that. Okay, so let's go look at one of, I think that was enough for us. I was trying to do these in reverse order. Okay, never mind. I'll just keep going. Here he says, determine the moment of inertia for the beam's cross-sectional area about the x-axis. So he's basically, here, I guess what I'll do. Okay. Grab this, go over here. We've already done this one. Let's move up a page. Drop it in here, maybe right there. Okay. All right, so there you go. So, going to be about the x-axis. X equals to something or other. Well, okay. You got a couple choices here. Where I'm going to choose to do it is I'm going to say here is one section here. And I'm going to go here and across here. So I'll call this one 1, this one 2, and this one 3. I don't really need to know Y bar here because now before I go on, let me say this. It is more often in mechanics and materials that you will need to do what this problem is stating. Is to find the centroid of the section and to find the I about that centroid of the section. There's a term that's called the neutral axis, and it comes out at you in mechanics and materials, and it is associated with that centroid of that section. So this is more typical of what you're going to do. This is an easier rendition. You're just taking the moments of inertia and moving them down. So first thing I'm going to do, I'm going to identify the centroids of each of these sections. Centroid of this section is right there. This is 1 inch. So now this becomes 7 inches. So this becomes 3.5. And that E1 means that it's up 4.5. This one, okay, move it off to the side. Its centroid is right there. Move this off to the side. Its centroid is right there. So this is up 1, up another. So this is 1, and this is 1. So this one's 2. And this is going to be a half, 1/2. So what I'm going to do is I'm going to list 1, list 2, list 3. The distance, okay, so I guess really first, maybe I want to do the area. The area of each of these, area of 1, say 10 by 1 equals to 10. Area of 2, which is over here, 7 by 1 is equal to 7. And then the area of 3, which is 2 by 1, which is equal to 2. Now, the distance I'm going to have to move to get their centroid, move to from local centroid to x-axis. Okay, so I'm going to have to move for 1. I'm going to have to move a ½ inch. For 2, which is over here, I'm going to have to do 1, 3.5. That's going to be 4.5. Over here, I'm going to have to do 1 and another 1. That's going to give me 2. And so now I'm going to go out and find I bar xx. Okay. Now, before I work any further, let me go back to this problem and say it really should be xx, but that's just me. Okay, so the centroid, 1/12, the base of 1 is this. Here's your base, 10 times height of 1 to the third is equal to 10/12. Okay, looking at the second one, which is this one, 1/12, the base of 1, the height of 7 to the third equals to, and I'll wait on that one for a second and do both these together. 1/12, the base of 1 and the height of 2. And so I'm going to do all these together. Let's see. The first one's easy. 10/12. 7 to the third divided by 12 is a number 28.583. 583. Second one is 2 to the third divided by 12, or 2/3. Now what I've got to do, I've got to add a portion of my a dy squared. That's a square. And that, okay, would be, let's see, a dy squared. Okay, just take the first one, 10 times 1/2 squared. Okay, 10 divided by 4. Let's just figure that out. And a 2.5. Okay, the a over here is 7 times the distance I got to move is 4.5 squared gives me, okay, hang on, 7 times 4.5 squared gives me 141.75, and then the 2 times the distance I got to move it squared, 2 times 2 squared equals 2. Why am I doing that? That's just 8. Okay. So now I've got to add this one and that one to get I bar xx. Okay, come on. Plus a dy squared equals to, okay, I got to go back and do this one. Okay, 10 over 12 plus 2.5 gets me 3 1/3, 3.333. I'm going to carry the digits instead. Okay, then I'm going to say 28.582 plus 141.75, 170.33, 170.33. You know what? I wonder if there's more 3s there. Yeah, I think there are, because 7 to the third over 12. Yeah, I think there are more 3s. Okay, and then 2/3 and 8. 8 and 2/3. 8 plus 2/3. I better just, okay. 8 plus 2 divided by 3. 8.666. I'm just going to leave it there. And now I'll sum these in this column to get 3.333333 plus 170 point. I think there are more threes there. Plus 8.6666, bunch of sixes, 182 and a third. 182 and a third. And if you look back at the answer, he's not including the third. So hope this makes sense. I think making a table is an organized way to do this. It makes it, he does a couple of problems in the book like that, but not all of them. So I started a few minutes earlier, so I'm gonna bail to start the fluids real quick, and we'll go from there, but I'll have a delay time.